Welcome all, welcome back at C squared. In this lesson we will talk about the equation of the circle, the standard form, and here at the beginning we're gonna get that equation, that standard form of an equation of a circle, and we're gonna start from the distance formula. If you remember, the distance formula looks like this: d equal square root of x2 minus x1 square plus y2 minus y1 square. So we have 2 points, and if you have these 2 points, you use this formula and you can get the distance from these 2 points. So in this case, I'm gonna call this one point 1, so x1 and y1, and this one x2, y2, and I'm gonna replace them in this distance formula. So let's see what we get now. So we have x2 minus x1, so in this case will be x minus h, so we just replaced this x coordinates with what you see in the picture. Very similar for the second part, y2 minus y1 becomes y minus k, and don't forget the square. Okay, now let's take a look to the distance between these points, the distance from T to A. What is this segment? This segment is the radius of the circle. So I'm going to replace it here. And I'm going to copy what we had in the previous step. And my next step will be to cancel the square root. And for canceling the square root, we need to raise to the second power. We're going to raise to the second power also on the other side, on the right side. So we have here r squared equal x minus h squared plus y minus k squared. This is the standard form of the equation of a circle. The only difference, we write it the other way. Remember, equality is commutative, so we have x minus h squared plus y minus k squared equals radius squared. So you notice, starting from the distance formula, we can develop this standard form of the equation of the circle. You see it down here also. Very important, the center is at h and k, the radius is r. Those are the things you need to know about a circle to write the equation. So let's see the first example here. We'll find the center and the radius of this circle, then graph the circle. So my first thing will be to write that equation we just discussed about, x minus h squared plus y minus k squared equals r squared. And very simple, I think you can see r squared is 25, right? Match r square root of 25. So for finding r, the radius, we have to take square root of 25, and that will be just 5. As you notice, I didn't put any plus and minus, no reason here. The radius is the distance, so it has to be a positive. How do we find h and k? Some of you may need to see this form. X minus 0 squared is the same thing with x squared, and y minus 0 squared is the same thing with y squared. So if you need to subtract that 0, though, that's okay, it means nothing, equals 25. So now we can look to these two forms and we notice h is 0. And obviously k, the same thing, k is 0. So that center of this circle is at 0 and 0. This is a circle with center at 0 and 0 and the radius of 5. So now I'm going to try to sketch a graph here. And the first thing you want to do when you sketch a graph, you start with the center. You start with the center. That is 0 and 0. And now count 5 units. Let's say right 1, 2, 3, 4, 5. Okay, this is good enough to draw the circle, but since I do not have the right tool, I'm gonna do the same thing vertically. 1, 2, 3, 4, 5. This is the second point that I can use. I can use a third point. 1, 2, 3, 4, 5, and I can use a 4 point. 1, 2, 3, 4, 5. I think with these 4 points I can sketch not a bad graph, not a perfect graph, but for sure, but a decent graph, I guess. This is the circle we have in this problem. It has a radius of 5 and the center at 0 and 0. Very similar to this problem, I'm gonna do a very similar approach. X minus h squared, you see I'm gonna write the equation, plus y minus k squared equals r squared. So I'm gonna start with the radius because I think it's the easiest one. Again, radius squared has to be 16, and that means the radius is gonna be square root of 16, which is nothing than 4. This is the radius of this circle. Now, h is not complicated. You notice it's right here. So h will be 2. But what about the k? For that k, maybe some of you may need to see something else. So I'm going to rewrite the given equation in this format. You see, I'm going to put a minus to match this minus we have here. And what should I put here? A negative 3. Y minus negative 3 is the same as y plus 3. So now you can see k is negative 3. A very good shortcut will be switch the sign. If it's a positive, switch the sign. The center is at 2 and negative 3. And the radius is 4. We can try to sketch a graph here. So let's see how that looks. So the center 2 and negative 3, I'm gonna go 1, 2, 1, 2, 3 down. This is the center. Let me change the color. And then we need to use this radius of 4, so I'm gonna count 4, 1, 2, 3, 4. Of course, graph paper will be helpful. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So now I think we can do a decent job here. And that's it. This is the circle with that we have the equation given in the problem. On my next part of the lesson, yes, sometimes you have to identify the equation of the circle from a picture. Yeah, you get a picture, can you write the equation? So on this one, first thing you want to do is to identify the center. In this case, if we take a look, the point T has the coordinates negative 4, you have to move 4 left and 3 up, right? So we're gonna have here negative 4 and 3. Okay, I'm gonna write it here. And what are these two numbers for us? Remember, this is the center. The negative 4 is the h, and the positive 3 is the k. So I'm going to write again that standard form of the equation of the circle, x minus h squared plus y minus k squared equals a radius square. So you notice we have h and k. We can just replace it here, and we have x minus negative 4 square plus y minus 3 square. And now we need one more thing, the radius. For that reason, you want to go back to point T and see if you can measure, if you can count for the radius. In this case, we can. If you notice, if I go 2 units, right, I go right here, and that is the circumference, and this is 2. That is how much the radius is. So see if you can get that radius from your picture. So we have here 2 square. One more step here is to simplify. X minus -4 becomes x plus 4 square plus y minus 3 square equals 4. That's it for this problem. And let's move to the next example, where we have something very similar. We have a picture and we need to find the equation. Sometime I want to be sure your picture is not going to be given and you have to plot these 2 points. Obviously you don't need to draw this circle, but plot these 2 points because that will help you. That will help you. We will see in the next minute or two how that will help you. So first of all, we know the center. So that T is the center. So very similar with the other problem. We know how much is h, how much h is -2. We know how much k is -3. So in that problem, in that standard form, I'm sorry, x minus h square plus y minus k square equals r square. We have h and k. We need to find the radius. For that reason, I said I think drawing the picture will help you in this case, because you see this is the radius, and if you do not remember the distance formula, you can use something else, which I'm going to show you. You can use the Pythagorean theorem. So you can use the distance formula, then you don't need a picture. But if you do not remember the distance formula, use Pythagorean theorem. If you notice, this is 2, this is 1, 2, 3. So we're going to do a square plus b square equals c square, the Pythagorean theorem, because this is a right angle here. So we have 2 square plus 3 square equal c square, and c, ladies and gentlemen, is nothing else than this segment, the hypotenuse of the right triangle, which is nothing else than the radius. I'll replace with the radius, is radius square. So we have 2 square, that is 4, 3 square is 9, that's his radius square. The last thing, we're going to add 4 and 9, and we get radius square equals 13. No need to do the radius, because if you notice, here we have the radius square. So now we can go back here and plug the things in. So we have what? X minus -2, that is how much h is, square, plus y minus -3 square, and the radius square, like I said, we have it, it is 13. So one more step to simplify inside of the parentheses. We're going to have x plus 2 minus -2 becomes plus 2 square plus y plus 3 square equals 13. This is the equation of the circle in the picture. Like I said, sometimes you do not have the picture, at least plot the points and you can use this method. On my next example, you notice you have what we call the diameter, right? You have these 2 points and these represent the diameter of circle T. So how are we gonna find the equation of this circle? Remember, the diameter is the largest chord, and in the middle you have the center. So sometime you can see it, like in this case, this is in the middle, this is the center, call it whatever you want. I'm gonna go and say C. What are the coordinates of point C? -2 and +5. Now if you cannot read that center, you can use what we call the midpoint formula. You have the 2 points A and B, find the midpoint, that will be the center. So, but in this case we can see it, so it's a little bit easier. We have h now. Good. We have the center, we have the k. The only thing we need to do is find the radius. Okay, so you have choices. You can use this triangle or the one on the bottom. It doesn't matter, they are both the same, congruent. If you notice, this is 1, this is 3, so I'm gonna have a squared plus b squared equals c squared. One more time, the Pythagorean theorem. And we're gonna have 1 squared plus 3 squared equals the radius squared, because this segment again is nothing else than the radius. So we're gonna have 1 plus 9 equals radius squared, so radius squared equals 10. And now we can go in that formula, x minus h squared plus y minus k squared equals radius squared. We're gonna go here and replace the information we have now. We have here x minus negative 2 squared plus y minus 5 squared. So these are h and k equals, and the radius squared is 10. One more step is to simplify the first parenthesis, and we have x plus 2 squared plus y minus 5 squared equals 10. That's it. Remember, this is a nice example. Sometime in order to find the center, you have to use the midpoint formula. Now let's move to what is called the general form. This is the general form of an equation of a circle. And sometimes you need to find the center and the radius for something like that. So this is my next example. We have this equation here. Can we find the center and the radius first, and then graph the circle and determine the domain and the range of the equation? So what you want to do here is to want to rearrange your equation. What do I mean by that? Let's take a look. X squared minus 6x. Then leave some empty space, you will see in a moment why. And then I'm gonna write here plus y squared plus 4y, leave some empty space, minus 12 equals 0. So I hope you agree with me, we have the same equation, we just have some empty space there. Now in that empty space you're going to put some number. Let me show you how you get these numbers. You're going to take this negative 6 and you're going to divide it by 2, and that will be negative 3, and then you're going to square it, and that will be 9. So what I want you to do here, I want you to put a plus 9. Since we add 9 here on the left side of the equation, we have to add 9 here on the right side. Very similar we're going to do with the y. You notice we have this 4 here. We're going to do the same process. 4 divided by 2 is 2. And then we're going to square these 2 and we get 4. So we're going to add a 4 here, and very similar, the same thing, don't forget, add a 4 here. So that is the thing, it's called complete the square. Why do we call this a complete the square? Because now this trinomial here, these 3 terms here, represent a perfect square. That will be x minus 3 squared. X minus 3 squared. Do you see that minus 3, right? Plus, what do we think is going to be this guy that we complete the square? And if you said y plus 2 squared, yeah, that is correct, because we have the 2 here. Minus 12 equals, and now on this side here we can add 0, 9, 4, that will be 13. One more step to get the standard form, right, is to add 12. So we cancel these negative 12, that's we add 12, and we have x minus 3 squared plus y plus 2 squared equals 25. Well, I'm going to move a little bit faster here. We have some experience now with the equation in the standard form of the circle. So what will be the center? The center will be positive 3 because it's x minus 3, remember? So that's good. We grab the 3. Now be careful here, y plus 2, so we need to say negative 2 here. And the radius will be square root of 25. Of this 25 you see here will be 5. So we have the first part of the problem after we complete the square. Now we're gonna graph it, and also just to graph this circle so you can do the last part, the domain and the range. And I'm gonna go here. Hopefully I'm gonna have enough space to get the domain and the range from this graph. So by now you know I'm gonna go to 3 and negative 2. So that'd be 1, 2, 3, negative 2. This is the center, right? And negative 2. And now we have the radius of 5. So very similar to what we did. The only thing probably I will suggest you here to do it is to try to label the points. What do I mean? So from this guy I'm gonna go this radius of 5 left and right. So let's start to write 1, 2, 3, 4, 5. So what will be this point if we move 5 right? So obviously the y coordinate, I'm sorry, we move, yeah, 5 right. Obviously the y coordinate stays, is going to be negative 2, is not going to change. The only thing that change is this x coordinate, and because we move 5 right, 3 plus 5 is 8. Very similar, we're going to move 5 left, 1, 2, 3, 4, 5. Of course, if you have graph paper, like I said in the beginning, it's going to be a lot easier. What are the coordinates of these points? So again, the y coordinate stays, doesn't change, negative 2. But the x coordinate change because I move from these 3, I move 5 left. So 3 minus 5, that will be negative 2. Now we have the domain. The domain of this equation starts from negative 2 and end up to positive 8. Remember, the domain stands for the axis. And I'm going to write it in 2 ways using this inequality. And you see I use x, and you have to put the equal sign because negative 2 and 8 are possible. There is one more choice, if you need it, is what we call the interval notation. It's this one, negative 2 and 8. How do we get the range? Very similar. Well, now we're going to start from this center and we're going to move up and down. 5 units, right? Because that's the radius. 1, 2, 3, 4, 5. What are the coordinates of this point? Since we move up, now the x coordinates stay the same. So it's going to be the same 3. The only thing that changes is the y coordinate, and since we move up, negative 2 plus 5. Is going to be 3. Let's move down 5 units. 1, 2, 3, 4, 5. What are going to be the coordinates of this point? So obviously the x coordinates stay the same. Doesn't change. It just move down. The one that changes the y coordinates, since we start from negative 2 and we move 5 down, we get negative 7. That will be the range. So the range for this equation will be from negative 7 to positive 3. From negative 7 to positive 3. Because is the range, I'm going to use the y, less or equal here, less or equal here. And yes, I'm going to put the interval notation in case you need it. Negative 7 and 3. With brackets on. And of course, my last thing here will be to try to draw a decent circle here, I'm not so sure about that, since I do not have the right tools. Okay, this is the circle. So again, in this case, you notice two things: complete the square and also graph the circle to find the domain and the range. These are my suggestions for you on problem like this. Last part of the lesson, we're gonna go a little bit deeper in this equation of a circle, and you notice I said here, yes, we can write this equation of a circle. Also, we can write equation of lines, in this case the tangent line. Like in this case, you see the same picture, but then it's in the rectangular grid. Can we use algebraic things to solve more problem, like the last problem on this lesson? You see here we have a circle T that has the center at -2 and -1, and the line L given by the equation 2x plus 3y equals 6. We need to find the point of the tangency. So what you want to do here, you want to start from this equation 2x plus 3y equals 0. You want to find the slope equals 6, I'm sorry. So for that reason, I'm going to subtract 2x, and I'm going to get here 3y equals -2x plus 6, and obviously the last step, divide by 3, and I get y equals -2 over 3x, and 6 divided by 3 is 2. Okay, what do I need here? I need this slope. Okay, the slope of this line is -2/3. Okay, and I'm gonna call it M1. This is the slope of the given line. Then I want you to do the negative reciprocal. So we flip it and we change the sign. That would be just 3/2, right? That is the slope of a second line that is perpendicular on line L. This is the line that contains the center and the radius, obviously, right? So let's find the equation of that line, and we have choices here. I'm going to use the point slope form, but if you want, you can use the slope intercept form. This is the form, and now we're going to just do y minus, and now of course we're going to use this point of the line given to us, the center, because that's the line we need to find out that goes to the center, and this is y1, so it will be -1 equals 3/2, the slope we found it, and parentheses x minus x1, x minus -2. So we have here y plus 1, equals 3/2 x plus 2. I'm going to use the distributive property here. Y plus 1 equals 3/2x if we multiply this. And how much is 3/2 times 2? That is just 3. So one more step, subtract 1, and we have y equals 3/2x plus 2. This is the equation of the line that is perpendicular on the given line, is the line that will contain the radius we're looking for. So how do we find now that radius? We need to find the intersection between these two lines. Line L, y equals -2/3x plus 2, and the one we found out, y equals 3/2x plus 2. Okay, so in this moment we have this system of equation, if you want to call it like that. we notice these two y, so we just make these two equations the same. Negative 2 over 3x plus 2 equals 3 over 2x plus 2. We kind of lucky here. Why? Because we can simplify this plus 2 on both sides, so it's a little easier, I think. We have negative, you know what, I'm gonna do like this, negative 2 over 3x, or let's put the x on top, equals 3x over 2. Okay, I think it's easier because now we can use cross multiplication, and we have negative 4x equals 9x. We want to solve for x, so we have to add 4x, for example, and we have here 0 equals 13x, and divide by 13 we get x equals 0. So ladies and gentlemen, this is the x coordinate of the point of tangency. How do we find the y coordinate? You can take any of these two equations and plug it in. Take this x equals 0 and plug it in here or in here. So let's say we're going to take the positive one, so we have y equals 3 over 2 times 0 plus 2, and you notice that will be y equals 2. So the point of tangency is 0 and 2. So now we know the center, it was given to us. We know a point. We can get the equation. But I want you to see for something, and this is the graph of what we did, and yes, it matched the math. Okay, so probably sometime you may want to do the picture. Plot this point, the center, graph the line, and try to get the shortest distance from your point to that line using the slope, right? Do you notice this is 3 and 2? So sometimes the graphical method works fine, just to point that in this moment. So but now I'm gonna go back here and I'm gonna erase, and I'm gonna want to find the equation of that circle in this empty space we have here. So last part. Okay, we're gonna have x minus h squared plus y minus k squared, and equals r squared. We know the center. We have x plus 2, right? It's going back here, square plus y plus k squared equals radius squared. We don't know the radius. We can do the graphical approach, but I want to show you a different way. This is the point of tangency. This is the x, this is the y. You can plug it here and get the radius. What do I mean? Let's take a look. 0, that is how much x is, plus 2 square plus, and I'm sorry, here it's supposed to be not plus k, it's supposed to be plus 1, right? Because we replace k with -1. So here we have 2 plus 1, the y coordinate of that point of tangency, equals r squared. So we have 2 squared plus 3 squared equals radius squared. This is 4 plus 9 equals radius squared. So the radius squared will be 13. So now we go back here and we have the equation. So we have here x plus 2 squared plus y plus 1 squared equals 13. Now there is one more part here which says find the equation for a second tangent line that is parallel to line L. So for that reason, if you want to use an algebraic process, that will take a little bit of time. You're going to take this point and the center and find the other point using the midpoint formula, and this is the other endpoint, and then the slope is going to be the same 2/3. But I want to remind you, this graphical approach, this guy, if you notice, is on the other side. So you can move from this point here, you can move 3 down. So 1, 2, 3, and 2 right. This is the point. So follow the same pattern, move down, and the slope is the same. And this is the line. For finding the equation, you use exactly what I did. I don't have any more space here, but if you come back on my channel, you may find this problem or a similar problem, and I'll do all the steps. But that's pretty much for today's lesson. If you enjoy it, don't forget to click the like button and come back on C-Square for more help. Thank you.